So starting with the first question, which is that complete the diagram to show the energies of the electrons in a carbon atom. Uh, to C plus and C minus one ions. So you have to basically orbitals draw करने, subshells draw करने. The first one is 1s. So that's already drawn for all of them. Carbon atom क्या होता है? What's the electronic configuration of 6 electrons? It's 1s2, and then you have 2s2, and then you have 2p. Uh, 2p, how many? That's 6. So 2p2. So that's the electronic configuration of a carbon atom. 1s के ऊपर कौन सा आएगा? That's going to be 2s, and it's going to have 2 electrons, and they're going to be paired. Okay, so both of them are going to be paired. And then you're going to have 2p, which is going to have 3 orbitals, 2px, 2py, and 2pz. And there would be only 2 electrons in them. अच्छा, so that's, और एक जो होगा ना, that would be empty. ठीक है, this is 2px, this is 2py, and this one over here is 2pz. तो कार्बन प्लस वन में क्या होगा? एक इलेक्ट्रॉन कम होगा. सो इट्स गोइंग टू बी द सेम थिंग एक्सेप्ट उसी के ऊपर करेक्शन कर लेते हैं कि ये वाला इलेक्ट्रॉन नहीं होगा. और कार्बन माइनस वन में they're going to be 7 electrons. 7 electrons, that means कि you're going to have 1 electron each. तो ये कार्बन माइनस वन का होगा. ठीक है, so I'm not going to do that again. तो कार्बन प्लस वन और कार्बन माइनस वन बड़ा बेसिक सा क्वेश्चन था. The next part is there's a Buckminster fullerene. और वो कह रहा है what is the hybridization of the carbon atom in C60? Uh, remember कि carbon had how many types of hybridizations? वो रिवाइज कर लेते हैं. It had 3 types of hybridizations. One was sp3 hybrid orbitals. कि कार्बन के पास टोटल 4 orbitals होते हैं outer shell में. A normal carbon has 2s1, 2px1. It has 4 electrons in its outer shell. ठीक है, it has 4 orbitals. लेकिन वो शेप चेंज कर लेते हैं when it bonds with other atoms. So the first one is Sp3 hybridization, in which what happens is the carbon atom is bonded to 4 atoms. So one electron gets pulled in one direction, the other one gets pulled in the other direction, the third one gets pulled in this direction, and the fourth one gets pulled in this direction. So there are 4 different atoms all pulling the carbon electrons in 4 different directions. And it ends up forming a tetrahedral arrangement. And all the angles are 109.5 degrees. And the other thing is these are known as, क्योंकि सारों की shape change होगी, all 4 orbitals they got stretched in different directions because the electrons were getting pulled in different directions. So you give them different names or new names. You start calling them sp3 hybrid orbitals. So that's carbon forming four single bonds with four atoms. ठीक है. Sarah, can you hear me properly? Sarah, समझ आ गया? Clear है? Ali, is this clear?
Yes, sir.
Yes, sir.
अच्छा, so we're going to revise everything. ठीक है, we're going to revise एक तो कार्बन की हाइब्रिडाइजेशन भी रिवाइज करते हैं, प्लस we're going to revise के कार्बन के कितने different structures होते हैं. अच्छा, the second type is कि carbon ends up forming is sp2 hybridized. Now, what happens in sp2 hybridized carbon atom? पहले तो ये clear होना चाहिए, whenever carbon is bonded to 4 atoms, 4 single bonds, तो वो it's tetrahedral. The next one is sp2 hybridized carbon atom. Now, in this, what happens is carbon had again 4 electrons in its outer shell. It had 2s1, 2p x1, 2py1, and 2pz1. But in sp2 hybridization, what happens is that three only 3 of the orbitals actually change shape because the carbon atom is bonded to 3 atoms. So one of the orbitals gets pulled in this direction. The other one gets pulled in this direction by a second atom, and the third one gets pulled in this direction. ठीक है? So तीन orbitals तीन different direction में stretch हो जाते हैं, and nothing happens to the fourth orbital initially. ठीक है? So there is this fourth orbital. उसके अंदर भी एक इलेक्ट्रॉन पड़ा हुआ है, but nothing happens to the fourth. अच्छा, तो जो फोर्थ इलेक्ट्रॉन होता है वो वैसे का वैसे ही होता है. नो वन इज एक्चुअली इनिशियली इंटरेस्टेड इन द फोर्थ इलेक्ट्रॉन. तो ये जो ऑर्बिटल शेप चेंज कर लेते हैं ना, ठीक है, वन ऑफ द ऑर्बिटल गेटिंग पुल्ड इन दिस डायरेक्शन, वन इलेक्ट्रॉन गेटिंग पुल्ड in this direction, and an electron getting pulled in that direction. ठीक है? These would be called your sp2 hybrid orbitals. You give them different names. And the fourth orbital remains unchanged. So p orbital, and this p orbital is involved in pi bonding. So first thing is, whenever you see carbon bonded to three atoms, that is going to be sp2 hybridization. Okay, that's the first thing. So I'm going to discuss structures. One very common example is an alkene. Okay, there's always going to be one pi bond. Both these carbon atoms are sp2 hybridized, which means this carbon atom, इसकी shape क्या होगी? This is going to be trigonal planar, and the angle would be 120 degrees. Okay, that's going to be the shape. Then you have तो ethene का molecule हम कर रहे हैं. Carbon is bonded to three atoms. एक ने इलेक्ट्रॉन इधर खींचना, एक ने इधर खींचा, the other one pulled it in this direction. And the fourth orbital initially, वो जो p orbital था, जो fourth electron था, nothing happens to it initially. The other carbon, same thing happens to it. It's bonded to hydrogens on one side and a carbon atom on the other side. So it's three of the electrons get pulled in different directions. Okay, so one went over here, one went over here, one went over here. The fourth electron, nothing happened to it in the beginning. तो जब दो ऑर्बिटल्स पैरेलल में आ जाते हैं, what do they end up doing? उनको भी इलेक्ट्रॉन चाहिए, वो एक दूसरे के इलेक्ट्रॉन्स को पुल करेंगे, and they would start overlapping above and below, and they would start forming a pi bond. So that's where the double bond comes in. So जब भी एक तो पहली चीज है carbon, whenever carbon is bonded to three atoms, that's going to be sp2 hybridized. And then there's one structure that you did in A2, which is benzene. In benzene, carbon is also bonded to three atoms. उसके अंदर what happens is that carbon, अच्छा उसके अंदर क्या होता है? Carbon is, so in benzene, I'm going to draw the, so in benzene what happens is that each of the carbon atoms, they are bonded to three atoms. ठीक है, ये इधर, so let's say these are the hydrogen atoms. ठीक है, I'm drawing the skeletal formula. ये बीच वाला जो है, that's the carbon atom. ये जो dots में डाल रहा हूँ, these are carbon atoms. Each carbon atom is making three bonds. ठीक है, so each one is making three bonds, and on the outside they're all bonded to hydrogen atoms. Now what happens in benzene is that each one has, they all have a fourth orbital, which is the p orbital, which is unchanged. अच्छा, just 1 minute, ठीक है, we'll continue after the azan. ठीक है, 1 minute break. चलिए ये continue करें. So each of the carbon atom was sp2 hybridized. It was making 3 bonds, 3 normal bonds, and the fourth electron. तो सारों का एक एक p orbital बच जाता है, and they start overlapping. वो सारे एक दूसरे को attract करना शुरू कर देते हैं, and the electrons they start overlapping. और वो जो overlapping है, that would happen at the end of the day. All of them would start overlapping with each other, because there are 6 orbitals now, all in parallel. So they all start to overlap. So at the end of the day, you get a delocalized electron cloud above and below the structure of benzene. Okay, so there's a ring of delocalized pi electron cloud. So we studied this as well, okay, in when we were studying the structure of benzene. So remember, sp2 hybridization happened in that as well. और ग्राफाइट के अंदर भी सेम चीज होती है. ग्राफाइट के अंदर you had अगर अगर वैसे हम डायग्राम, क्योंकि it's going to take a lot of time to draw. Graphite is like, अगर कोई स्ट्रक्चर मिल जाए, just a second. ठीक है, जैसे ये probably अच्छा, so this one benzene की तरह ही है, ठीक है. It's the same carbon atoms, hexagonal rings, and each one they're forming 3 bonds, and one p orbital uh, is unchanged, and all of them had a p orbital, and they start overlapping, and at the end of the day you get a delocalized electron cloud that's spread everywhere. So इसलिए graphite electricity conduct करता है, because it has, each carbon atom has a p orbital. There's going to be a p orbital over here, there's going to be a p orbital with this carbon atom, and they would all start overlapping, and they would form a delocalized electron cloud, which is why it conducts electricity. ठीक है, ये clear है सारों को? सारा is this clear? Abu, is this clear?
Yes, sir.
Yes, sir.
Achha, anyways, the question, and there's one more, which is sp hybridization. What is sp hybridization? In sp hybridization, usually you don't see that in organic chemistry, uh, but in sp hybridization, carbon is only bonded to 2 atoms. Okay, so sp, so it has a total of 4 orbitals, but it's only bonded to 2 atoms. So how does that work? The way it works is, okay, one of the orbital gets stretched in one direction by one atom, and in the other direction by the other atom. So 4 orbitals में से ना, 2 of them they get stretched in different directions. ठीक है? Uh, Whereas 2 orbitals remain completely unchanged. So there's going to be a p orbital that would be completely unchanged, and there's going to be another p orbital on another axis, z axis के ऊपर. That would be unaffected. ठीक है? But in total you had 2s1, 2px1, 2py1 and 2pz1. तो इसमें क्या होता है कि it's only bonded to 2 atoms, so one electron gets pulled in one direction, the other gets pulled in the other direction. So 2 of them they change shape. You start calling them sp hybrid orbitals. Okay? Because you can't call them s because they're no longer spherical. You can't call them p. You give them different names. और जो बाकी दो है ना, they remain completely unchanged. तो वो जो red और green वाला है, that's completely unchanged. So how does bonding happen in that के तो उसके अंदर 2 pi bonds बनते हैं, because now you have 2 orbitals which are capable of forming a pi electron cloud. So you can get two pi bonds now. This is a carbon dioxide का molecule. In a carbon dioxide molecule, exactly the same thing happens. कि carbon का एक orbital और एक orbital इधर. One bonds to oxygen, the other also goes and bonds with oxygen. Then carbon has a spare orbital, a p orbital, which is not bonding. So an oxygen also has a spare orbital which is half filled. तो वो दोनों एक दूसरे के साथ overlap करते and they end up forming pi bonds. ठीक है एक side पे. So there's a double bond on one side. But then this other oxygen also has a spare p orbital on a different axis, and this carbon also has a spare p orbital. तो वो different plane के अंदर they start overlapping with each other, and they end up forming another pi bond on that side. So at the end of the day, you get two pi bonds. ठीक है? ये clear है?
Yes,
Yes,
sir.
sir.
अच्छा तो sp2 sp3 sp hybridization. Just remember the simple way to remember this is sp3 is tetrahedral when it's bonded to four atoms. sp2 is going to be trigonal planar, and it's going to happen it's going to form a pi bond, a single pi bond, and it happens when bonded to three atoms. Whereas sp hybridization happens when it's only bonded to two atoms, and then it's going to form two pi bonds. Uh, it can form a double bond on both sides, or it could form a single bond on one side and a triple bond on the other side, as long as it's bonded to two atoms. As I'm moving on, we have to revise this. We have to revise the structures that are formed by benzene, not benzene by carbon. So, the structures that carbon forms, you should know all of them. Uh, so we're going to one by one. Mic किसी का on है. Please turn off the mic. अच्छा, so one by one we're going to discuss the structures of carbon. ठीक है, जो AS के अंदर आपने पढ़े थे. The first one is diamond. Obviously, you've studied diamond all the time. Diamond is the tetrahedral arrangement. ठीक है, diamond is this arrangement. It's the sp3 hybridized arrangement of carbon atom. What happens in diamond is that each carbon atom is bonded to four different other carbon atoms, and माइक देख लो कोई अच्छा, so this one. So diamond is the one which is sp3 hybridized, tetrahedral, each carbon atom bonded to other carbon atoms, and it's a continuous structure. Graphite is the sp2 hybridized arrangement. Graphite के अंदर what happens is you have sheets, ठीक है, ये वो level से पढ़े हो, layers and sheets of carbon, which are all sp2 hybridized. So they have delocalized electrons. And then based on graphite, you have three other different structures. कि अगर आप ग्राफाइट की शीट को एक्सट्रैक्ट कर लो ना ग्राफाइट में से, one single sheet of graphite. Remember, graphite is very soft. उसकी जो sheets है ना, they are not attracted to each other very strongly. They only have weak van der Waals forces. There is no bonds. There are no bonds between them. So if you are able to extract a single sheet of graphite, that's called graphene. And graphene is a very sensitive, it's a highly conductive substance, and it's a very strong material, and a very useful thing, especially in uh, medical imaging, because of the sensitivity of the material and because of the excellent electrical conductivity. Now, based on graphene, recently this nanotechnology has developed, which is that these graphene sheets can be rolled into tube-like structures, which are known as nanotubes. These same graphene sheets which were extracted from graphite can be rolled into ball-like structures like fullerenes. So you can make small nanostructures, small tiny nanostructures, which are in high demand. I mean, this is something that has recently happened. Okay? Previously, it was kind of impossible to extract a single sheet of graphite. Now they've developed technology to easily extract graphene and graphene. ठीक है इसी तरह जैसा कॉपी है ठीक है the sheets of pages all stacked on top of one another. uh, you can't really make structures out of or out of a book, but if you pull one page out of it, if you pull one sheet out of it, you can make very good structures, ball like structures, nanotubes, etc. अच्छा इनका फायदा क्या है? नैनो ट्यूब का फायदा ये है कि इट्स अ hollow cylindrical thing. So उसकी applications क्या है? Applications ये है कि if you have a nanotube, the way you can apply this nanotube is कि this nanotube खास तौर पे drug delivery के अंदर can be very useful. Why? Because let's say here's this. Here's a nanotube. ठीक है, it's a graphene sheet that's been rolled into a tube-like structure. What's going to happen is a nanotube can secure your drug molecules. For example, if you're taking medicine, medicine molecules have to. Most of the medicine is actually taken in orally. Most of it, because injecting medicine is kind of very inconvenient for most people. So now the problem with oral intake of medicine is that it has to go through the stomach, and the stomach is going to digest it. It's going to break it down. So, so a very few. If you take 1,000 molecules of, let's say, Panadol, the amount of molecules that would actually go into your bloodstream would be very few because a lot of them are going to get digested or broken down by the acids in the stomach. So, so the problem with that is you have to take high doses of uh, of medicine so that they can enter your bloodstream through the stomach, because most of it is getting broken down by the stomach. So if you have a nanotube, what a nanotube would do is that it's a hollow structure, and these medicine molecules can enter the nanotube, and they can be protected by they can get some protection. It's like a tiny capsule, a very tiny capsule at the molecular level. Okay. So so the medicine, I mean, this tiny cylinder could actually move through the stomach, and your medicine could remain safe. So lower doses would be taken, and they would be able to reach your bloodstream more easily. ठीक है? ये clear? Sara, is this clear? Abu Rera? Ali, is
Yes,
this
sir.
clear?
Yes, sir.
Yes, sir. Other than carbon hybridization, in paper 4 we get questions on shapes of molecules. Can we
On
revise that also?
on what thing?
Shape of molecules. Shape
हाँ
of
मतलब
molecules.
shapes पे तो आएगा. Shapes मतलब वो तो fundamental चीज है ना. Questions are going to come on shapes. ठीक है? But chemical bonding is जो AS पे chemical bonding है, that's, I mean, that's you'll be asked anything about it. ठीक है? All of it is can come in A2. अच्छा अब इसका ये कि so that's what a nanotube is, or Buckminster fullerene जो है ना, that's or fullerenes to be specific. Uh, it's the same thing. तो वो कह रहे हैं कि what is the hybridization of the carbon atom? ठीक है? So we pretty much revised everything. So what's the hybridization? It's sp2. ठीक है? Remember, it's a derived compound of graphite. When graphene sheets get rolled into और उसकी bonding से भी देख लो. मैंने क्या बताया था कि when carbon is bonded to 3 atoms, that's sp2 hybridization. अच्छा, next one is कि C60 reacts with an excess of hydrogen to form a single product. Use your answer, suggest a suitable value for X. तो अच्छा, C60 is reacting with hydrogen. अब what did I tell you about hybridization? कि sp2 hybridization में कार्बन के 3 ऑर्बिटल जो हैं, they have already bonded. So there's only one spare orbital left. तो अगर हाइड्रोजन रिएक्ट कर रहा है, तो each carbon can make an extra bond if it's capable of making an extra bond. So it's only going to make one extra bond. carbon is already making 3 bonds. So the only possibility is that the fourth orbital, which was involved in pi bonding, also gets involved in bonding, and at the end of the day, you get a tetrahedral structure that all four are bonding. Okay? So since this is all of them are sp2 hybridized. Okay, think of it this way, that there's a fourth, each carbon atom has this fourth orbital, a fourth spare orbital. तो अगर hydrogen react करेगा तो how many hydrogens will get added to it? Exactly 60 hydrogens. ठीक है, because each carbon can actually make one extra bond now. If it's capable of making that bond, it's going to make one bond. ठीक है, exactly the same way as if you have an ethene molecule and a hydrogen atom gets added to it. So how many spare orbitals does it have? It only has one. एक फालतू का orbital पड़ा हुआ है. That's the only one that could bond. So one extra hydrogen could get bonded over here, one extra hydrogen could get bonded over here, and the double bond would break. ठीक है, the same is true for benzene. Okay, how many hydrogens would get added to it? There's all of them. They have one spare orbital, so each one can make an extra bond with one hydrogen. और फिर pi bond खत्म हो जाएगा because there would be no spare orbitals left. ठीक है, is this clear? सारा clear है? बुलेरा clear है?
Yes, sir.
यस सर.
अच्छा
सर वो क्या कहते हैं P5 कैंसिल हो गया.
कैंसिल का नहीं मुझे पता, ऑप्ट आउट किया हुआ लोगों ने.
यानी कंफर्म नहीं है अभी.
नहीं, वो तो तुम लोगों से ऑप्शंस मांगे थे ना, तुम लोगों ने क्या दिया ऑप्शन?
नहीं मैं तो यही बोला था कैंसिल कर दो.
तो कैंसिल मतलब तो वो
यानी
मेजॉरिटी
स्कूल पे डिपेंड करता है.
हाँ, मेजॉरिटी ने तो ऑप्ट आउट किया ना.
अच्छा.
मतलब मैं नहीं जानता किसी को अभी तक जो P5 एक्चुअली दे रहा हूँ. ठीक है.
अच्छा.
अच्छा, दिस वन वो चेक कर लेना, कंफर्म कर लो ना, P5 की भी प्रैक्टिस कर लेंगे. अच्छा, दिस वन benzene reactions. Give the reagents and conditions for these two reactions. Now this is, और इसको भी रिवाइज कर लेते हैं. The first one is the first reaction number 1 is not a reaction of benzene at all. ठीक है, एक सेकंड देना, मैं बोर्ड लोड कर लूं. Just 1 second, reloading the board. अच्छा, so reaction number 1. Not a reaction for benzene. It's a reaction of this branch of carbon जिसके अंदर Cl आके अटैच हो गया. ठीक है, ये इसमें सबसे पहला रिएक्शन पड़ा था. This was the reaction called free radical substitution, which जिसके अंदर you required UV light and Cl2. So this was free radical substitution. Just briefly going over what happened in free radical substitution was, okay, what happened in free radical substitution? There was a first step number 1, which was known as initiation. Remember, organic and then AS सारा revise करना पड़ेगा. So there's going to be step number 1, which is initiation. And what happened in the first step was that you had a chlorine molecule, and the chlorine molecule would break down homolytically. कि एक इलेक्ट्रॉन वापस इसके पास चला गया, इसका एक इलेक्ट्रॉन वापस इसके पास चला गया, and that would result in, एक तो अभी क्लीन कहाँ से होता है, once again, ठीक है. अच्छा, so it would break down homolytically and it would produce two radicals. ठीक है, 2 Cl radicals are going to be produced. और ये सनलाइट की वजह से होता था, यूवी लाइट की वजह से. And the other thing was कि once this happened, तो जो मर्जी कार्बन चेन है जिसके अंदर हाइड्रोजन हो, ठीक है, that was then you had the propagation step. Okay, what's going to happen in the propagation step? कि you had ठीक है जो मर्जी कार्बन चेन है with hydrogens and there would be a Cl radical. Cl radical को अपना इलेक्ट्रॉन वापस चाहिए. It's a highly electronegative element. तो what it would do is कि it's going to उसको हाइड्रोजन के इलेक्ट्रॉन्स नजर आएंगे. तो हाइड्रोजन के इलेक्ट्रॉन को खींच के वो अपने साथ जोड़ लेगा. ठीक है, it's going to pull the hydrogen atom away from the carbon atom. और ये इलेक्ट्रॉन कार्बन के पास वापस चला जाएगा. And that would result in the formation of the carbon would become the radical. कि उसका जो H है ना वो Cl ने अपने साथ जोड़ लिया, HCl बन गया. ठीक है, और फिर इस तरह वो कंटिन्यू करता रहता था कि अब कार्बन को बॉन्ड चाहिए होते थे. तो what it would do is कि it's going to pull electrons from Cl and bond with them. और ये इलेक्ट्रॉन वापस इसके पास चला जाता था. So the carbon chain would have a Cl attached और Cl radical फिर फॉर्म हो गया. और ये बस चलता रहता था. Cl radical would come in, attack the carbon chain, take away the hydrogen, और कार्बन चेन रेडिकल बन जाती थी. वो फिर Cl के रेडिकल्स को अपनी तरफ पुल करता. And then there was the third step which was the termination step. Termination step was that any two radicals could just simply join up. कि अगर आपके पास you had if you had a carbon chain that's in the form of a radical and if there's a Cl radical, radical क्या होता है जिसके bonds complete नहीं होते थे, they would simply join up. और उस केस में भी ना the end result would be कि कार्बन चेन के अंदर ना Cl आ जाता था. So that was free radical substitution के कार्बन चेन के हाइड्रोजन्स के साथ if you want to substitute them with Cl, you use UV light and Cl2. So that was the first reaction one, उसके reagents and conditions. The other is the reaction of benzene, specifically benzene. कि उसके अंदर how would you put a Cl in the benzene structure? तो बेंजीन का जो रिएक्शन होता था उसको इलेक्ट्रोफिलिक सब्स्टिट्यूशन कहते थे. ठीक है, दैट वाज इलेक्ट्रोफिलिक सब्स्टिट्यूशन. Those were the reactions for benzene. And what would happen in those reactions was that you had a benzene. उसका mechanism और उसकी conditions वगैरह कर लेते हैं. अच्छा, you had a benzene and there was a pi electron cloud. ये भी ऊपर हमने देखा भी था कि this was the structure of benzene. That there were the Sp2 hybridized all of them, and there were p orbitals which were overlapping and forming a ring of delocalized electron cloud. तो अच्छा, Cl2 का मॉलिक्यूल ना इसके साथ आके रिएक्ट करता है. The Cl2 molecule is acting as an electrophile. Because there's so many electrons over here, ठीक है, this ring represents the electron cloud. The electrons in the Cl2 molecule are going to be repelled. And one of the Cl would become partial positive, the other one would become partial negative. And the positive Cl would be attracted even more by the electrons. And the negative Cl would be repelled even more by the electrons. So एक Cl attract हो रहा होगा, and the other Cl would be getting repelled. So the polarization of Cl2 molecule happens. But the polarization is not very strong. The reason it's not very strong is कि benzene का जो pi electron cloud होता है, that has a very low density because उसके electrons बहुत ज़्यादा distributed होते हैं. But if you look at this p orbital, so you would realize that this particular p orbital जिसको मैंने shade किया, not only is it overlapping with लेफ्ट साइड वाले कार्बन आटम के साथ ओवरलैप कर रहा है, but at the same time it's also overlapping with the carbon on the right side. तो दोनों साइडों पे ओवरलैपिंग कर रहा है, which is why the electrons are kind of more distributed, ठीक है, more spread out. So the ring of delocalized electron cloud, the pi electron cloud, it has a very low charge density because the electrons are very distributed. ठीक है, दोनों साइडों पे pi bonding कर रहे हो तो electrons जो है वो ज्यादा distribute हो गए. So which is why the polarizing power is not very high. इसका जो positive charge बनेगा ये इतना बड़ा नहीं होगा, and because of that it's not going to be very strongly attracted to the electrons in the benzene. इसलिए for this reaction, for this specific reaction, you need a catalyst. और catalyst कौन सा use करते थे? Fe, Cl3 और AlCl3 catalyst use करते थे. ठीक है, transition metals are very good catalysts. The reason is they have a very large number of protons compared to normal metals. And they have this tendency to attract electrons. So this is exactly what happens कि Fe दूसरी साइड से ना उसको further polarize करता था, वो electrons को अपनी तरफ खींचता था. And at the end of the day, आपका जो molecule होता था ना, that would get polarized. Cl-1 टूट के उस साइड पे चला जाता था, and the Cl positive would then be attracted to the benzene, and then you had this mechanism that was happening, which was कि benzene एक second draw कर लें. अच्छा, तो ये Cl+1 हो गया, and the other one is Cl-1, right? The molecule has been polarized and it has been broken successfully. So FeCl3 ends up forming a dative bond. ठीक है, Cl-1 comes in and forms a dative bond with Fe. Fe pulls it to itself. और फिर end में ये -1 charge जो है ना इस पूरी चीज के ऊपर होगा. This entire thing would be -1. अच्छा, what happens to Cl+1? तो उसके ऊपर देख लेते हैं कि अगर यहाँ पे ड्रॉ करें Cl+1 would come in और Cl+1 जो है ना वो इनमें से एक p ऑर्बिटल के इलेक्ट्रॉन्स को अपनी तरफ पुल करेगा. सो दिस p ऑर्बिटल would be gone because its electrons are going to be pulled towards Cl+1. तो आपका जो इलेक्ट्रॉन क्लाउड होगा that would become partial, क्योंकि इधर वाला p ऑर्बिटल कौन ले गया? वो Cl+1 has taken that electron. So this is what happens. Okay, Cl+1 comes in and it bonds with one of the carbon atoms. उसके p ऑर्बिटल को खींच के अपने साथ जोड़ लेता है. So the electron cloud becomes partial now, but it's present everywhere except on that carbon atom. A carbonium ion is formed. And there's one H as well over there. Just 1 second, the board is hanging up. अच्छा, so there's one H over there as well. और अगले step में होता है कि substitution happens. The H, क्योंकि the benzene electron cloud is electron deficient, तो वो अपना electron वापस दे देता है. And the benzene electron cloud becomes complete again. So that is what electrophilic substitution is. And remember that to get a chlorine or a bromine onto a benzene ring, you need electrophilic substitution. You need a catalyst for that. Or reaction number 2 के अंदर the catalyst that would be required would be FeCl3. ठीक है, that's going to be your catalyst. Plus the reagent would be Cl2. ठीक है, सारा, is this clear? Abu Rera, clear है?
Yes, sir.
And 2 electrophilic substitution reactions happened. One was with chlorine, the other one was with bromine. Same thing with bromine, it's going to be FeBr3. And then there was nitration of benzene, which was also electrophilic substitution. So let's continue with the same paper, ठीक है? Topic wise इसको revise भी करते रहेंगे. कल पे continue करते हैं, ठीक है?
Okay. Good off.
चलिए मैं इलेक्ट्रोफिलिक सब्स्टिट्यूशन के ना मैं लेक्चर्स भी शेयर कर देता हूँ ग्रुप के ऊपर, ठीक है, ताकि वो रिवाइज कर लो। ओके देन, टेक केयर, हाफिज।